Okay, so now we'll see the Varignons theorem of moments. Okay, the Varignons theorem of moments. Okay, so according to the Varignons theorem of moments, the statement is the algebraic sum of moments produced by the forces about the moment center. Okay, the algebraic sum of moments produced by the forces about the center is equal to moment produced by the resultant about the same center. Okay, the algebraic sum of moments produced by the forces about the center is equal to moment produced by their resultant about the same center. Okay, what is the meaning of this is, if there are two forces F1 and F2, assume there are two forces F1 and F2. Now this is a force F1. Okay, let this be F2. Okay, there are two forces F1 and F2, and let their resultant, the resultant of these two forces, be R. Got it? Now this is your x-axis, let it be your y-axis. Now there are two forces F1 and F2, and R is the resultant of the force F1 and F2. If you consider a point here, say this point to be O. Okay, now let d1 is the distance of F1 from O, that is the perpendicular distance of F1 from O. This is a perpendicular. Let this be d1. Okay, that is d1 is the perpendicular distance of force F1 to point O. Similarly, let d2 be the distance of F2 from point O. Let d2 be the distance, that is let d2 be the perpendicular distance. Let d2 be the perpendicular distance of F2 from point O, and let d be the perpendicular distance of resultant from point O. Okay, so there are two forces F1 and F2, and the resultant is R. Okay, now there are two forces F1 and F2, and the resultant of F1 and F2 is R. d1 is the perpendicular distance of F1 force from point O, d2 is the perpendicular distance of F2 from point O, and d is the perpendicular distance of resultant from point O. Now what Varignons theorem states? So according to Varignons theorem, the algebraic sum of moments produced by the forces. Algebraic sum of moments means what? What is the moment? Moment is force into perpendicular distance. Now I am considering moment about point O. Okay, now algebraic sum of moments means, okay, algebraic sum of moments produced by the forces. Now if you consider F1 force at point O, what is the moment? Force into perpendicular distance, that is F1 into d1. Okay, that is F1 into d1, right? The algebraic sum of moments, again there is one more force, that is F2, and distance is d2, so F2 into d2 plus F2 into d2. Okay, now see here, the algebraic sum of moments, produced by the forces F1 and F2 about the center is equal to moment produced by the resultant about the same center. Now if you consider moment about point O, then F1 d1 and F2 d2 should be equal to, plus F2 d2 should be equal to, resultant is R into moment is D, R into D. That is the algebraic sum of moments produced by the forces about the center. So F1 into d1 plus F2 into d2 is the algebraic sum of moments produced by the forces, is equal to moment produced by their resultant. Moment produced by the resultant means what? Again resultant into distance is resultant of moment. Okay, so is equal to moment produced by the resultant about the same center. So simple. So F1 into d1 plus F2 into d2 is equal to R into D. That is the moment produced by the forces is equal to moment produced by their resultant. Simple. The moment produced by the forces is equal to moment produced by their respective resultant. It is the meaning of Varignons theorem. Okay, now there are some formulae to be remember in a non-concurrent force system. So the formulas are, you can see here, which is similar to concurrent force system only. So formula to remember in non-concurrent force system. So first resultant is equal to under root summation fx square plus summation fs square. Theta is equal to again tan inverse summation fy by summation fx. Now third is we know this formula, that is r into d is equal to f1 into d1 plus f into d2. Now f1 into d1, f1 into d is what? Summation of moments only, right? F1 into d1 is also a moment, f2 into d2 is also a moment. That is nothing but summation of moments, moment plus moment plus moment, and so on. So summation of moments. So r into d is equal to summation of moments. So d is equal to summation of moment divided by r. Similarly, x-intercept of the resultant is summation of moment divided by summation fy, and y-intercept is summation of moment by summation fx. So here you should only consider the magnitude, don't consider the sign. So these are some formulae to remember in non-concurrent force system. Now on this we'll try to solve some simple problems. Okay, so the question here is determine the resultant of non-concurrent force system shown in figure. Also find moment about point A. This is point A. Okay, moment about point A. Okay, and determine the intercepts. Intercepts means the value of d, the value of x, the value of y. That is the value of d, value of x, and value of y. So the question is first to determine the resultant. So what is the resultant? R is equal to under root summation fx square and summation fy square. So we need to find the value of r. Okay, so now r is equal to under root summation fx square and summation fy square. So to find the value of r, we need to find the value of summation fx, we need to find the value of summation fy. Okay, and then to find the moment about point A. Okay, now first we'll find the value of r. Okay, you can see here I am redrawing the figure here. Okay, now this is point A. From point A at a distance of 1.5 meter 20 Newton is acting. From this 1.5 meter 30 Newton is acting. From this 3 meter 20 Newton is acting at an angle 60 degree. Okay, and here is a point B. Now you can see here this 20 Newton is clearly acting along negative y axis. 30 Newton is acting clearly on negative okay, and this 30 Newton is acting clearly along negative y axis, that means acting vertically downwards. And 20 Newton acting in which quadrant? You can see here, if you don't understand, at this point or this point, imagine a quadrant. If you imagine a quadrant here, now you can see it is first, it is second, it is acting in the third quadrant at an angle 60 with horizontal. Okay, at an angle 60 with horizontal. That means, let me redraw here. This is acting like this. This is acting like this. This is 20, this is 60. 60 with horizontal, 60 with horizontal. This is 20 cos 60, this is 20 sin 60. So you can see here, I am redrawing the figure here. This is 20 Newton acting vertically downwards, 30 Newton acting vertically downwards, and this 20 Newton acting in the third quadrant. So this is 20 cos 60 component, this is 20 sin 60 component. You can show here or either here. Both are correct. Okay, now this is acting purely along negative y axis. If you don't understand, at this point or this point, just imagine a quadrant. You can see here it is acting purely along negative y axis, Now first, to find the resultant, first let me find summation fx. Summation fx is equal to what? So summation fx is equal to, this is 20 acting vertically downwards or purely acting along y axis, its component is 0. 30 Newton acting purely along negative y axis or vertically downwards, its x component is 0. So you can see here 20 cos 60. Okay, it is acting along negative x axis, so minus 20 cos 60. Okay, that is equal to, okay, so 20 cos 60 is 10, so it is minus 10 newtons. Okay, or you can say 10 Newton acting along negative x axis. Both are correct. Summation fy. What summation fy means? Addition of y component of all the forces. 20 Newton acting vertical downwards, or you can say negative y axis. So minus 20. 30 is minus 30, and you can see here 20 sin 60 is also acting along negative y axis. So minus 20 sin 60. That's equal to, so minus 20 minus 30 minus 20 sin 60. It is 67.32. 67.32 minus 67.32 newtons. So R is equal to under root summation fx square plus summation fy square, under root summation fx square plus summation fy square. So is equal to, so square plus 10 square. Square root of answer 68.05. 68.05 is the answer. So it is 68.05 newtons is the resultant, and theta is equal to tan inverse, consider only magnitude, summation fy by summation fx, that is equal to, if we do it, if tan inverse 67.32 divided by 10, it is 81 degree. It is 81.5 degree or 81.55 degree. Okay. Now this is over. That is finding r and theta is over. Now the next question is to find moment about point A. So I'm writing here summation of moment about point A is equal to, summation of moment about point A is equal to, okay. Now you can see here, first what is the moment? Moment is force into perpendicular distance. Moment is force into perpendicular distance. If the force is vertical, distance is horizontal. If the force is horizontal, the distance is vertical. Okay. Now first we'll consider 20 Newton force. So moment at point A due to 20 Newton force is how much? Force into perpendicular distance, 20 into 1.5. So right here 20 into 1.5. Now it is clockwise or anti-clockwise. You can see here from this arrow mark along the distance to a given point, imagine an arc. Okay, you can see here it is completely it is clearly clockwise. So plus 20 into 1.5. Then we'll consider 30. So moment at point A due to 30 Newton force is how much? So again force into perpendicular distance, 30 into distance to point A from 30 Newton is how much? 1.5 plus 1.5, totally 3 meter. 30 into 3. It is clockwise or anti-clockwise. You can see here from this point to this point along the distance, imagine an arc. You can clearly see it is a clockwise. So plus 30 into 3. Okay. Now moment at point A due to 20 cos 60 is how much? So if you remember, if a force or its line of action is passing through the given point, then moment produced by that force and that point is 0 because there is no perpendicular distance. So you can see here 20 cos 60 is acting here. If you produce a line, if you produce this line of action, you can see here it is passing through the point A. So 20 cos moment produced by this force at this point is 0. Then we'll consider 20 sin 60 force. So again force into perpendicular distance, 20 sin 60 into 3 plus 3 is 6. Again it is clockwise. So plus 20 sin 60 into 6. Okay, 20 sin 60 into 6 is completes. Okay, now that's equal to, okay, remember here force into perpendicular distance, so 20 into 1.5, 30 into 3. Moment produced by this force, you can see here it is horizontal. This force is passing through the given point A, so there is no moment produced by this force at this point. Only 20 sin 60 into distance is 6. So the answer is, so this is 223.9 Newton meter. Now once you find the summation of moments, we know the formula, that is D is equal to summation m by r, x equal to summation m by summation fy, y is summation m by summation fx. So directly apply the formula. D is equal to summation of m, that is 223.9 divided by r is 68.05. This is equal to, and x is equal to summation of moments again 223.9 divided by summation fy. Summation fy is minus 67.32, but here we will only consider the magnitude, that's equal to, and y is equal to summation of moments 223.9 divided by summation of x is minus 10, but consider only sign. So this is equal to, okay, so 3.29, 3.326 and 22.4. This completes the problem. Okay, so the question is to find resultant and moment about point A and the intercepts. So this is summation of x, summation of y, moment D and x and y. Okay, so the next question is just to find moment of force F is force F, okay, about point A, given F as 600 newtons. So you can see here F is acting this point. We need to find the moment about point A. Now where F force is acting, so you can see here F force is acting in which quadrant? It is acting in the third quadrant. It is passing through the first quadrant and going in through third quadrant. Okay, so to find the moment about point A, so given force is acting here. Now you can see here where force is acting. So this is the arrow mark here. You can see here, this is the arrow mark. This is how force is acting. Now where force is acting, if you imagine a quadrant here, it is passing through the first quadrant but actually acting in third quadrant. So in third quadrant, we know the components. This is the x-axis, this is the x component. So this is 600, this is 30, with horizontal it is 30, means this is 600 cos 30, and this will be 600 sin 30. This will be 600 sin 30, right? So moment about point A is equal to force into perpendicular distance. So this is 600 cos 30 component, this is 600 sin 30 component. Force into perpendicular distance, first we'll consider 600 cos 30 is the force into, I want perpendicular distance, force is horizontal, distance should be vertical. You can see here, this is a force, this is perpendicular distance, that is 0.2, it is 0.2. Now it is clockwise or anti-clockwise. From arrow mark to the given point along the distance, imagine an arc. You can see here it is anti-clockwise, so minus. And force produced by 600 sin 30 at point A is how much? So this force is passing to the given point. So we know that if a force or its line of action passes to the given point, then the moment produced by that force on that point is 0. So only moment of point A is 600 cos 30 into 0.2. 600 cos 30 into 0.2, it is 103.9. So minus 103.9 Newton meter.